Welcome to YouTube channel Abrar Electrical World. This is purely voluntary free education YouTube channel, no commercial activity. So we have uploaded at least 10 video lectures and 5-6 in classroom settings where I have explained everything, all the aspects starting from why system studies, what is transient steady stability, then what is the rotor angle, how the generator go out of synchronism, what is the acceleration, why deceleration of the alternator, what is the power swing, what is the power torque angle, what is the mechanical power, electrical power, what is equilibrium, everything I have explained in the classroom setting. Also power swing detection and power swing blocking and out of step tripping, islanding, that I have explained in various lectures in the classroom. Now in this particular 2-3 lectures I am using the very important report on the power system disturbance and the power system transient stability, and it was prepared by a team of engineers and scientists in collaboration with the IEEE Institute of Electrical and Electronics Engineers USA, and it is very comprehensive report, and therefore I thought that I must mention this in my banner because I have taken the material from this report. So it is also moral duty to quote and to mention and to offer thanks to those team of engineers who have really prepared such a wonderful research thesis and paper. So I have prepared 3-4 lectures or the video presentations from this paper. Therefore, on the main title I have mentioned the papers. I recommend that this paper must be studied by the students who intend to do the MS or PhD. So this is not a purely theoretical paper. This is based on the actual happening and the breakdown in the New York State long time ago. I think 2 decades at least ago, and then this study or research was carried out. So I have taken the help from this. Now coming to this topic, that power swing blocking. So by now you have read the power swing, what is power swing, what is the stable power swing, what is unstable power swing. There is a lecture from me with the heading power swing stable dash unstable. So you can also go through that so that you understand what is the power stability, transient power stability, and what is the power swinging, and what is the bad effect of the power swinging. It results in the inadvertent, unwanted mal-operation of the relays. Distance relays operates because it sees power swing as a fault at that point because it measures the voltage and current. So there are various methods which are in use in the power system, and I have mentioned in my other lectures in the classroom. But in this lecture, the mostly I have given the written information, and I have picked up the information from this wonderful, well-researched paper which is mentioned here. So please go through that paper as well, because I cannot take everything from there. I have taken some points and then mentioned here, and all the explanation are of my own, from my own experience, and they are also mentioned in my classroom lectures with the hand drawn diagram and the interactive sessions with the student. Now, what are the conventional power swing blocking? They are known as conventional, but you can also write the same power swing blocking method. And that is, there is no difference. So what is the fundamental basis? Fundamental basis I have explained by other lectures also, that it measures the impedance. How does it measure the impedance? Actually, it does measure means what? It does measure means the relay which are required to give the trip signal in case of a real fault. What they do? Basically, the distance relay, they measure the voltage and current. When there is a fault, the voltage collapses or start reducing and the current is start increasing due to the fault. Therefore, the ratio of V by I changes, and V is less and I is greater, then it means that the measured impedance is going down, and then ultimately it comes closer to the relay setting of the distance relay, third zone, fourth zone, it will come immediately. Then if this measured value enters into your setting, then definitely the relay is going to operate. So this is the basic fundamental of the blocking. So as soon as the load point or the measured value of impedance touches or comes closer to the final to the largest relay setting, third zone or fourth zone, then the relay starts measuring and sensing that there is a fault, and after a certain time the relay will give a trip command. So this is the basis of everything in this one. So how do they achieve, how these are achieved? So this is written here again, that the difference between impedance rate of change during a fault. So what happens when there is a fault? The rate of change of the V and I is very rapid. That very rapidly the voltage goes down and very rapidly the current increases. So rate of change of the measured value or the VI is much faster as compared to the power swing. So this is one of the indication that if you compare the rate of change of the measured impedance with the rate of change of the measured impedance during the fault and without the fault, then there is a big difference. So therefore, when there is the time that it is very slowly, the ratio is changing, the measured impedance is changing very slowly, and then it is assumed to be a power swing, and in that case the relay is blocked for that period. Therefore there shouldn't be any mal-operation or the unwanted tipping signal initiated by the distance relay. So basic theory is what? Basic theory is the measurement of the rate of change of impedance and comparing the rate of change of impedance during the fault with the rate of change of measured impedance during the power swing. So the rate of change of impedance, measured impedance during the power swing is much slower than the rate of change of measured impedance during a fault. This is the basic fundamental principle of detecting the power swing and then ultimately blocking. When you when you are able to detect that it is a power swing, then immediately it is easier that the relay should be blocked for that period, that the tripping signal should not be initiated by the distance relay, sensing that this is not a fault, this is a power swing. And power swing, in short, we have always written the power swing blocking. So for this, what we do, we create the concentric characteristics, and the concentric characteristic is setting is on the outer side of the largest setting on the relay. Suppose there is third zone setting in the circle or the parallelogram or the lunatic or the polygon, what kind of, the larger, there will be drawn another fictitious characteristic with a certain impedance, and that will be used if this is crossed by the measured impedance value, then there is an alarm that something bad is going to happen, that the measured impedance is being changed. So that is an alert sign, and if it crosses it, then the measurement rate of change is already there, is being measured, and if it crosses or comes closer to the real setting, then in that period relay has a time to block the power swing, or also it may sensing the power swing, it may initiate the out of step tipping at certain predefined locations, so that the system can be run in the islanded mode or can be saved from going apart from each other with a large angle. So this is known as, see here, suppose this is your highest third zone, inner, and then there is outer zone. See, inner zone, outer zone. So this is a fictitious zone. This does not initiate any relay tripping signal, but whenever the line impedance, measured impedance somewhere here, and it moves in decreases because VII decreases. You can see my other lectures, I have mentioned this. So if it is increasing here and crosses from here, it touches here, then the relay alerts that there is some kind of a irregularity or instability coming up. And when it is traveling through this time is noted, and if this time is more than the preset, is less than the preset, then the relay blocks, the relay is blocked, so that it is a power swing. And if it is changes very rapidly, then it does not block, because that is considered to be a fault. So these are the images. I have drawn my own images in my classroom lecture. You can refer to that also, so that you have a clear idea. Now, these are very useful, but there are some drawbacks for this, because the load encroachment also come into this, the normal heavily loading. So this is not very widely used, but this is still used. Then there are blinded schemes, as you draw the parallel lines as compared to the impedance line. I will show the scheme, then you will understand well. See, these are the blinders here. Blinder means another setting parallel to this distance relay, that is the line impedance. See, this is the locus shown here. If the power swing crosses here, then this time is noted, and this rate of change in this period determines whether it is a fault or it is a power swing. Sometime the system becomes stable, and the power swing is stable, and the load point again returns to some other point outside the boundary of the distance relay. So these are known as the blinder. The single blinder has two, and the double blinder has the two set of blinders. So if the swing still persists on, crashes and crashes and crashes like this, then the relay understands that this is a unstable power swing, and it blocks the distance relay from tipping, because it is taken as the power swing. So see, there is single blender scheme as well, but double blender scheme is preferred usually. So now this is a third method. I have uploaded a classroom setting whiteboard lecture on this one, where I have clearly shown that how the continuous impedance or the slope is measured. The rate of change of the y and x, or say x and r, is measured after every 5-second interval, and that delta, if it changes rapidly from one and then second one, the third one, so they are compared with each other, and if the rate of change is very rapid of the delta, or the m value or the k value, that is the tangent delta, tangent of the angle, it is not delta, that is the rotor angle, it is the angle of the x and r here on the I recommend that you go through my lecture, which has a heading of continuous impedance measurement for power swing blocking series. So in that one I have clearly shown how this is measured, and what do I mean the rate of change of impedance which is continuously measured. So in that lecture it is very clearly mentioned. So I hope I have covered every aspect with the help of this paper. Please go through this paper, which I mentioned in the first slide on the banner. That is very important, and for MS and PhD students, they must also read that kind of papers if they want to increase their knowledge. But these papers are also very useful for the field people working in field, because from these kind of paper they analyze actually the root cause of the disturbance, and then they also offer solution for that. So I again offer my thanks to the writers of those paper, and I strongly recognize the effort by the team. Thank you very much.